Let's talk about one of the most important materials that literally built the world around us, metal. But these things aren't just, boring lumps of rock. They've got some seriously impressive abilities. You might even call them superpowers. I mean, really think about it for a second. From the massive steel beams holding up our tallest skyscrapers to the tiny copper wires that are bringing this explainer to you right now, metals can do things that other materials just can't. So what's the deal? What's their secret? Well, first off, they are incredibly strong. They can handle immense weight and pressure without even breaking a sweat, which, is exactly why we build our entire civilization with them. Then there's that signature shine, right? That amazing luster that has fascinated people for thousands of years, from ancient gold treasures to polished chrome bumpers. And here's a really weird one. You can bend them. You can hammer a piece of metal into a super thin sheet or draw it out into a long wire, and it won't shatter. How wild is that?
And of course, they conduct heat and electricity like champs. Okay, so we've got strong, shiny, bendable, and conductive. Let's dive in and find the one single secret that's behind all of them.
All right, let's line up these superpowers. These are the classic properties you probably remember from a high school science class, the very things that make metals so unbelievably useful to us.
So, you know the drill. Most are solid at room temperature, and they have incredibly high melting points. Just think about the intense heat it takes to forge steel. They're shiny, they conduct energy really well, and they are both malleable, meaning you can hammer them into shape, and ductile, which means you can pull them into wires. The big question is, why? What makes them do all this?
Well, the answer, the single source of all these superpowers, is not something you can see on the surface. Nope. For this, we have to zoom way, way down to the atomic level, to a really cool and kind of strange idea called the sea of electrons. So here's how it works. When a bunch of metal atoms get together, they pack themselves into a really tight, organized grid. But here's the thing about metal atoms. They're super generous. They don't hold on very tightly to their outermost electrons. Instead, those electrons just leave home. They detach and become part of a huge, mobile sea of negative charge that flows freely around all the atoms. The original atoms, now missing an electron, are positive ions, like a grid of little islands floating in this shared electron sea.
And that right there, that attraction between the positive metal islands and the negative sea flowing all around them is the metallic bond. This is the whole secret, right here. The crucial point is this shared sea of electrons. It's the glue holding everything together, but, and this is key, it's a flexible, flowing glue.
Okay, so how does this whole flowing glue idea explain why you can bend a metal spoon, but if you try to do the same thing with, say, a salt crystal, it would just snap in half?
Well, check out the difference. When you put force on a piece of metal, the layers of those positive ions can just slide right past each other. And that sea of electrons, it just flows right along with them, keeping everything stuck together. But if you try that with something brittle, like salt, you force positive ions right next to other positive ions. They repel each other like crazy, and the whole thing just shatters. And that, right there, shows you the unique magic of the flexible metallic bond.
But this amazing electron sea isn't just about bending and not breaking. That same exact principle is responsible for two more of metal's most famous traits, its conductivity and that classic shine. This part is actually super simple. Because you've got this sea of electrons that are free to move anywhere they want, what happens when you apply a voltage? Well, that whole sea of electrons starts flowing toward the positive end. And what do we call a flow of electrons? Yep, an electric current. It's that easy. Their freedom to just roam around makes metals the perfect conductors.
So what about the shine? You guessed it, it's that same sea of electrons. When light hits the surface of a metal, those free electrons get all excited. They absorb the light's energy for just a split second and then immediately shoot it right back out as a new particle of light. It's like the surface is a perfect trampoline for light, bouncing it right back into your eyes. And that's what we call luster.
So metal is already amazing all on its own. But of course, we humans couldn't just leave it at that, could we? We figured out that if we mix metals with other elements, we can actually tweak their properties and design custom supermetals.
We call these mixtures alloys, and you can honestly just think of them like a recipe. You take a base metal, add a pinch of this, a dash of that, and you end up with a material that's often way better and more useful than any of the individual ingredients.
The perfect example is steel. Pure iron is pretty strong, sure, but you mix in just a little bit of carbon and you get steel, which is dramatically stronger. Why? Well, the tiny carbon atoms sneak in between the bigger iron atoms and basically just get in the way. They make it much harder for those layers of iron to slide past each other, and voila, you get something that is so much stronger and harder. And we can even change an alloy's properties just by using different ways to heat it up and cool it down. So there you have it. From bending and shaping to conducting electricity and shining bright, it all comes back to one simple, elegant idea deep down at the atomic level. So, at the end of the day, what's the big takeaway here? It's that every single one of metal's so-called superpowers, its strength, its shine, its flexibility, its conductivity, it all comes from that one core concept, the metallic bond. It's that shared, flowing sea of electrons. That's the secret sauce that allows us to shape metals, to power our world with them, and to engineer incredible new alloys for just about every piece of technology we rely on. Learning how to master metals completely changed the course of human history. Our entire industrial and technological world is, quite literally, built on this invisible sea of electrons. And it really makes you wonder, doesn't it? What new atomic arrangements, what new kinds of seas will be the foundation for the world of tomorrow?